All right, let's take a look at Chem 11, Sample Exam 2, question number 17. In this question, we were asked to write reaction equations with the complete products and with the products as well as the balanced molecular, ionic, and net ionic equation when it is applicable, in other words, when there is a reaction. If there's no reaction, then you have to write it with NR. So let's start. We have to look at each of these reactions. And remember that we can write all of these reactions here if there is double displacement reactions, right? And you have aqueous species. So let's see what kind of reactions we have. The first reaction is barium hydroxide with nitric acid. So we just have to write this out first, which hopefully means that you still remember all your nomenclature information. So BaOH2 is aqueous and nitric acid is HNO3. So this is of course your standard acid-base reaction. It's also a double displacement reaction, so I can find the product by swapping my cation with the anions, giving me the equation. If I balance it, I put a 2 there on the water because I'm going to need a 2 here also on the nitric acid. So that's the molecular equation. And then for the complete ionic, remember what you have to do is you have to write the separated ions for the aqueous species. So in this case, we're going to have Ba2 plus 2OH minus. I'm going to take out the aqueous for now because we're going to cancel out some spectator ions, as you remember. 2H plus, 2 nitrate, and then we have barium ion, 2 nitrate ion, and then water stays the same because it's liquid, and so the spectator ions in this case is barium and nitrate, and so the final equation is just 2H plus aqueous plus 2OH minus, also aqueous, forming 2 water. Or you can also simplify this by just writing H plus OH minus going to water liquid. Let's take a look at the second reaction. It says lead nitrate and sulfuric acid. Well, lead nitrate PbNO32. Sulfuric acid is H2SO4. This is a double displacement, potentially a reaction, so let's write out the potential product first, PbSO4, and the other product is HNO3. Okay. Now HNO3 is a strong acid, so it's going to be aqueous. The question is what's PbSO4? So you have to remember to your solubility rules here. And in your solubility rules, all sulfates are soluble with certain exception, lead being one of the exceptions. So this is actually going to be a solid. And so if that's a solid, that means there is a reaction. We're going to write out our complete ionic equation by separating out all the ions in the aqueous state. Pb2 plus 2NO3 minus plus 2H plus SO4 2 minus. And then the solid stays together, and I didn't balance this earlier. I'm going to put a 2 here to balance that out. So we have 2H plus and 2NO3 minus. And of course, what we can do at this point is remove the spectator ions from the equation. That's H plus and NO3 minus, leaving us with Pb2 plus SO4 2 minus, both aqueous, forming PbSO4 solid. Okay, the last reaction is a combustion reaction of methanol. Methanol's formula is given there, CH3OH. So methanol is a liquid. Combustion means a reaction with oxygen gas. And remember, when these organic compounds are being combusted, you have 2 products. CO2 is one and H2O is another. So to balance this out, it should end up giving you 4, 2, 3, and 2. Okay. Now, if you look at all the species here, none of them is aqueous. They're all liquid or gas. That means that they're not going to break apart into ions. They're all covalent compounds. So they're just going to stay as they are. So there's no net ionic equation. There's no complete ionic equation for that reaction. Okay.